Okay, so to find those important points, those critical values to help us solve a rational inequality, we're going to look for any x-intercepts, and we're going to look for any vertical asymptotes and any holes. Basically, it's any place where the numerator or denominator equals 0. Any number that would make a numerator or denominator 0. You do have to make sure one side of the inequality is equal to 0. If it's not equal to 0, you can adjust that if needed. One side of the inequality is 0 first. They turned off my air purifier over here. It's quiet. Okay. So thinking about this inequality here, there's two numbers that would make a numerator or a denominator equal to 0. 5 and -3. Very good. The number that would make the denominator is going to equal to 0 is going to be a 5. X equals 5. The number that would make the numerator, my purple pen is running out, numerator equal to 0 is going to be x equals what? -3. Now the reason I write them separately is because they get different endpoints depending on whether it was a numerator or denominator. The denominator, since technically it can never actually equal that number, it's not allowed, it would make it undefined. The denominator's endpoint on the number line is always going to be an open dot. It's always an open dot for the denominator. Open dot. So, like so, when we graph it. But the numerator's inequality, open or closed dot, is always just based on the inequality symbol in the problem. So in the problem it has a less than symbol, not a less than or equal to symbol. So based on that, will it be an open or a closed dot? Open dot, right. So the numerators is based on the inequality symbol. So for this one, it'll be open. Open dot. Okay. So denominator is always an open dot. The numerator is based on the inequality symbol in the problem. So we found those two numbers. So we're going to take those numbers, we're going to plot them on our number line. Both of them we found out were open dots. So we'll need an open dot on 5 and an open dot on -3. Okay, and if you remember what we did when we had inequalities before, what did we do with each section? We checked, yeah. We basically picked a number in each section to see if it would be a solution or not by taking a number in that area, plugging it into the original inequality, and just checking to see is that less than 0.
-4.
Okay, so checking -4 is a good one. Let's do that. Test x equals -4. So on the numerator, I'll have -4 plus 3. And on the denominator, I'll have -4 minus 5, which would be a -1 over a -9, which is a 1/9. Is 1/9 less than 0? No. Okay, so we're not going to have solutions to the left of -3. And then we'll check a number that's in the middle. -1. 0, so easy, Mason.
0.
I'm going to test 0. Test x equals 0. So on the numerator, I'm going to plug that in. I'll have 0 plus 3. On the denominator, I'll have 0 minus 5. 0 plus 3. 0 minus 5. And we're checking, is that less than 0? Yeah, that would be -3/5, which is less than 0. Yes. Okay, so if 0 is a solution, then all the other numbers in between here will also be a solution. And then checking, good. On the right, 10 sounds great. Test x equals 10. So on the numerator, we'll have 10 plus 3. On the denominator, we'll have 10 minus 5. And we're checking to see, is that less than 0? Nope, that would be 13 over 5. And 13 over 5 is not less than 0. So we don't have solutions on the right-hand side either. So where are we going to shade? In between, right. And my shading, I don't get super technical. I just usually draw a line that connects them. And then lastly, we're going to put our answer in interval notation. Interval notation is what?
Is the one where you do the D thing.
More specific.
It's the brackets. No. But it's like the squiggly one.
Not the squiggly one, no.
Is when you do 0, 1, parentheses, quickly brackets.
Parentheses and square brackets. Parentheses. So for this open dot on the -3, are we going to use a parenthesis or a square bracket? Parenthesis. And the -3, and then we'll put a comma. And then on the 5, we're going to use a parenthesis or a square bracket. Parenthesis on the 5. Very good. And since it only had one interval, we don't have to use a U to combine it with another interval. Yeah, that one wasn't bad. The second one's not bad either, I promise. The only thing about this second one we have to think about is for that numerator, we probably want to factor the numerator first so we can see what two numbers would make that numerator 0. So factoring the numerator, that is just easy factoring. We'll need two numbers that multiply to -6, but they also add to -1. -3 and 2, good. So my numerator, we can put those directly in there, will be x minus 3, x plus 2, and my denominator is still an x minus 1, and we have a greater than or equal to 0. So just checking, one side has to have a 0 first. Is one side is a 0? Yep, good on that. Okay. And now to find the critical points, we need to think about numerator and denominator separately. Denominator is always an open dot. So for my denominator, what number would make my denominator 0? When x is 1. This one is always an open dot because we can never actually equal that number. Open dot. Okay, now the numerator is going to be based, the symbol for that one is going to be based on the inequality symbol. So for my numerator, I have two numbers that would make the numerator 0. 3 and -2. Very good. And based on this inequality symbol, are we going to use an open or a closed dot? Closed. So we're going to have 3 points on our number line for this one. Notice the tip, careful even with less than or equal to or greater than or equal to. Don't always assume all your critical values are going to be closed dots because the denominator is always an open dot. Yes?
It says x minus 3 and x plus 2 on the refactor. It says, oh wait, never mind. I'm a little confused.
It's okay. It's early. It's early. Alright, let's put our critical values on that number line. Let's see, I'm going to have an open dot on 1 because of my denominator. Okay. And I'm going to have a closed dot on 3 for the numerator and another closed dot on -2 for the numerator. So that creates quite a few areas that we need to check for solutions. We need to check to the left of -2. We need to check between -2 and 1, between 1 and 3, and then to the right of 3. Alright, starting with to the left of -2, what would you like to test? -3?
No, it's too hard.
-3 is too hard? You can plug it into the original, you can plug it into the factored one. It shouldn't matter, you should get the same answer. I'm going to use the factored one. So I would have -3 minus 3, which would be -6. And then -3 plus 2, which would be -1. And then on the bottom, I would have -3 minus 1, which would be -4, which is 6 over -4. Is that going to be greater than or equal to 0? No, why not? That's obvious. It's negative. A negative can't be greater than or equal to 0. So this one's a no. Okay. Number in between -2 and +1? 0, yeah. Okay, so for the first parenthesis, I have 0 minus 3, which is -3. 0 plus 2, which is 2. And then 0 minus 1, which is -1. That's -6 over -1, which is 6. Is that greater than or equal to 0? Yes. So we will have solutions in between these two. And then checking, I'm just going to use 2 so that I don't have to use a decimal for the next one. Test x equals 2. So I'll have 2 minus 3, which is negative 1. 2 plus 2, which is 4. 2 minus 1, which is 1. So that's negative 4 divided by 1, which is negative 4. Is that greater than or equal to 0? No. And then lastly, checking something that's greater than 3. 4. So that'd be 4 minus 3, which is a 1. 4 plus 2, which is a 6. And then 4 minus 1, which is a 3. So that would be a 2. Is that greater than or equal to 0? Yes. So we found 2 areas where we would have solutions. So I'm going to shade where those areas are. One of them was between the negative 2 and the 1. And then the other one was to the right of the positive 3. And then don't forget, let's also write our answer as an interval. Is this one going to have a U? Yes. How can we tell? There's 2 separate intervals. This one and then this one. Starting with the first interval, that's going to be, I'm going to write negative 2 comma 1, and then let's determine our end symbols. What end symbol for the negative 2? Square bracket. What end symbol for the 1? Parenthesis. And then we'll put our U. And then we'll pick up and we'll have our 3, but what symbol on the 3? Square bracket. Comma, what are we going to with this arrow? Infinity. And what end symbol on infinity? Parenthesis. These notes are actually pretty clean. There's not a whole lot of scratch work. Okay, backside. What's wrong with it? There's a 2, and we need one side to have a 0. Can we just multiply by 0? No, I wish. I'm going to put a little note here. Make one side 0. Make one side 0. So yeah, Sean said we could subtract 2. That's what we're going to do. So now I have 3x minus 5 over x plus 2 minus 2 is less than or equal to 0. Okay, we got one side equal to 0, but I do just want one fraction on that left-hand side. We learned how to do this last week. This is technically adding and subtracting. I could get a little common denominator. What common denominator would I use? X plus 2, right. So I would just have to multiply the numerator and denominator by x plus 2. Let's see. So that would be 3x minus 5 over x plus 2 still. Minus. And then this one would be 2x plus 4. What'd you say?
Why are we doing this?
Because we need it to look like the ones on the front.
Why do we make one side equal to 0?
To see if it's less than or equal to, greater than or equal to 0.
But can we do it like if this is how come?
Because you can't. Honor, lift your head. Thank you. Danny, lift your head. Okay. Now, let's do it. We got common denominators. We're going to keep that denominator the same. What do we do with those numerators, though? Subtract them. So starting with 3x minus 2x, which is x. Negative 5 minus 4, which is negative 9. Mason, would this be the same 2 numbers we would have gotten if we would have just started with the beginning and did what we did on the front? No, it would not have been the same 2 numbers. That's why we can't do that. Okay, so now looking at what makes my numerator 0, what makes my denominator 0. Denominator is going to be negative 2. And that one's always going to be what type of dot? Open dot. For the numerator, yes, it would be a positive 9. And that one's going to be closed because that one is based on the inequality symbol in the problem. Mason, can you wake him up? Pick up your pencil. Pick it up. Thank you. Problem's not going to write itself. Okay, let's plot those 2. And again, as Mason said, like, Could we have just used the 2 starting from the beginning, but would we get those same 2 endpoints? No, we would have got -2 and 5/3, so we can't just use it from the beginning. We want one side to have a 0 and then one fraction on the left. All right, plotting my 2 numbers that I found -2 open dot and +9 close dot. Okay, that creates how many areas that we need to check for solutions? 3 areas, yes. Okay, so starting with to the left of -2, what number would y'all like to test? -3. So on the top we'll have -3 minus 9, which is -12. On the bottom we'll have -3 plus 2, which is -1. So that's basically 12. Is that going to be less than or equal to 0? Yes? No? Common sense. Is that less than or equal to 0? No. Okay. And then a number in between -2 and 9. 0. Always nice to use 0. Test x equals 0. So we'll have 0 minus 9 on the top and 0 plus 2 on the bottom, which is -9 over 2. Is that less than or equal to 0? Yes, because it's a negative number. And then testing a number that's to the right of 9. 10. Yes?
If one of the, since those are endpoints,
Mm-hmm.
that means that only one part of a line can be like connected to them. So that means like every other like region is shaded.
The only stipulation to that is sometimes all of them are shaded, and sometimes none of them are shaded.
They wouldn't be endpoints.
I have seen it to where 2 of them in a row are shaded. That's why I always check. I have seen it. Yes, I know. Isn't that crazy?
Why are they called endpoints?
I don't know.
Oh, okay. I guess
Is my last one a yes or a no?
I guess if it's an open dot, that would be the only way,
Mhm.
as well as if there's.
Yeah. Okay, where am I going to shade? In the middle. And then that's going to make my interval -2 and 9. Very good, Mason. Parentheses and square bracket. We getting it? Okay. We got this though. So we need one side to have a 0, which means we need to either subtract the left or subtract the right. What side y'all want to make a 0?
The left or the right side.
Yeah, I like the right side being 0. So I'm going to subtract that whole fraction. But can we just subtract them right away? Why not?
Because they're not the same denominator.
They're not the same denominator. -3 over x plus 1 is greater than 0 now on the right.
Multiply by the lowest common denominator.
Yes. What would be my least common denominator?
X minus 3 and x plus 1.
LCD would be, yes, x plus 1, x minus 3. Yes. Mm-hmm.
Whenever we have anything, we should always put the
Yeah.
Every
It's important.
problem.
How do I get this one to be the LCD? Multiply by x plus 1, because it already has an x minus 3. The second one already has an x plus 1. What else does it need to be the LCD? X minus 3. Not the whole thing. Just you're just trying to get common denominators. And then simplifying my numerators, I'm going to have a 5x plus 5 over x plus 1, x minus 3. Minus, and then my second numerator is going to be 3x minus 9 over x plus 1, x minus 3. Now that they have the same denominator, what are we allowed to do? Nope. Cancel what out? Subtract, yeah. Subtract the numerators. The denominator is going to stay the same when you add or subtract. So we'll have 5x minus 3x, which is a 2x. we'll have 5 minus negative 9, which becomes 14. And then denominator stays the same when you add or subtract, just like it did in the first grade. All right, so we got to look at what makes my numerator 0, what makes my denominator 0. I usually start with the denominator. I don't know why. There's actually 2 numbers that would make your denominator 0. Negative 1 and 3. And both of these get what type of dot? Open dot. Okay, and then my numerator, there's only one number that would make my numerator 0. Negative 7, right. 2 times negative 7 would be negative 14, plus 14 would be 0. You can always take this and set it equal to 0 and solve it. This one's symbol is going to be based on the inequality symbol in the problem. According to the inequality symbol in the problem, is it an open or a closed dot? Open, yep. So these are all open dots. Okay. So we need open dot on negative 1, open dot on 3, open dot on negative 7. So 4 areas that we need to check for solutions. What number would y'all like to check that's smaller than negative 7? Negative 10? Okay. So let's see, on the numerator we'll have 2 times negative 10, that's negative 20. Plus 14 would be negative 6. On the denominator we'll have negative 10 plus 1, which is negative 9. And then negative 10 minus 3, which is negative 13. So that's negative 6 over a positive number. And what's a negative divided by a positive? A negative. Is that going to be greater than 0? No, a negative number is not going to be greater than 0. So it really doesn't matter what it is. It just matters what its sign is. We would have negative 6 over a positive number. I don't know. You want me to go up to the side and do the multiplying? It doesn't matter what number it is. All that matters is what number it is. It is, yeah. Okay. In between negative 7 and negative 1. Negative 5. 2 times negative 5, that would be negative 10. Negative 10 plus 14 is a 4. On the bottom, negative 5 plus 1 would be a negative 4. Negative 5 minus 3 would be a negative 8. So that's 4 over 32, which is a positive number. Is that going to be greater than 0? Yes. Yes. Yeah, it really just matters whether it's positive or negative. In between negative 1 and 3, sounds good. 0 works. Let's see, on the top we'll have 2 times 0 plus 14, which is 14. On the bottom we'll have a 1 times a negative 3. So that's 14 over negative 3, which is a negative number. Is that greater than 0? No. Negative numbers are not greater than 0. Okay. And then one last, something to the right of 3. 5. 2 times 5, that would be 10 plus 14 is 24. Over 6 times 2. 24 over 12 is 2. Is that greater than 0?
No, yes.
Yes, it's a positive number. Yeah. So I'm going to shade the 2 areas where we found solutions. We found solutions in between the negative 7 and the negative 1. We also found solutions to the right of positive 3. So I'm going to write out those 2 solution intervals. Are we going to have to use a U in our answer? Yes, because we are connecting 2 intervals. So we'll start with negative 7 to negative 1. What type of in symbols? Parentheses on both. And then we'll have 3 to infinity. And what type of in symbols? Parentheses on both. All right.